Alright guys, geometry, lesson 11, the volume formula of a pyramid and cone. But as always, before we get started guys, make sure you hit like, make sure you guys subscribe, and make sure you guys are ringing that notification bell so you guys get messages when these videos come out immediately. So, let's jump in. What's the formula to find the area of a triangle? Well, the area of a triangle is equal to 1/2 base times height. Now, why does this work? Well, we have this really cool thing with triangles and this geometric transformation that we can do that changes the shape but doesn't change the area. It's called a shear. And so we can change the shape of any triangle to look like a right triangle. Now, if we have a right triangle, that means that it's half of a rectangle or half of a square. And so the area of a rectangle is base times height. And if we have a right triangle cut from that, we know it's going to be half of that area. So again, it's 1/2 base times height. The volume of a triangular prism is, we're just going to take this and we're just going to keep building layers on top of it. So we're going to take this base area, I'm going to call it base area, and we're going to multiply it by our height of this prism. Now, why does this work? Again, it's just because we're building these layers on top of each other. But if you guys really want to know, it's a calculus thing. So when you guys get to calculus, you'll be able to see it, and it's really cool, trust me. The volume of a cone or a pyramid is really similar to the triangular prism or any prism. The volume of a cone or a pyramid is 1/3 base area times height. So again, why does this work? It's really a calculus thing. But if you guys remember back in 8th grade, hopefully your teacher showed you this. You can take a cone that has the same base area and height as a cylinder, and it takes 3 of those completely full to fill that cylinder. It's a really cool little demonstration of why that works. So now we have a cone that fits in a cylinder, so their bases are the same and their heights are the same. We need to find the volume that's inside the cylinder, outside the cone, and in an exact answer. And an exact answer means that we're going to be talking about it in terms of pi. So let's find the volume of the cylinder first. Volume of cylinder is going to be pi r squared times h. So 25 pi times 12, which gets us 300 pi. Now the volume of the cone is 1/3 of that, so it's 100 pi. Which means that our area outside the cone, inside the cylinder, is 200 pi. I hope that makes sense, guys. We're just taking the volume of the cylinder and we're subtracting the volume of the cone from that. A square pyramid has a volume of 245 cubic inches. I'm going to draw this out because that helps me. That always helps me, drawing it out. And then we're going to write out the formula. So volume equals 1/3 base area times height. So let's start filling things in. It has a volume of 245 cubic inches, so 245 is equal to 1/3. The height is 15 inches. What's the area of the base? We need to find base area. Well, first, let's divide both sides by 15. That's going to give us, I want to say what's 245 divided by 15? I want to say it's 16.3 repeating. So then we get 16.3 repeating is equal to 1/3 of our base area. So to get rid of that 1/3, we're going to multiply both sides by 3. So that's going to get us 49 is equal to our base area. So then what's the length of one side? Well, we're just going to take the square root of that. So one side is going to be equal to 7 inches squared. So as you guys are working through problems like this, it really helps to not only draw a picture, but to write out the base formula and start filling in numbers as you can. That really helps me out. So in the diagram below, answer the questions that follow. Determine the volume of the cone shown below, give an exact answer. Well, in order to find the radius here, we need to use Pythagorean Theorem. So we've got the square root of 137 squared is equal to 11 squared plus r squared. Well, the square root of 137 squared is 137 is equal to 121 plus r squared. Subtract 121 from both sides, you get 16 equals r squared. which means that r is equal to 4. So if r equals 4, we're going to find our base area. Well, our base area is equal to pi r squared. So we're going to get 16 pi. And then to find our volume, we're taking 1/3 base area times height. So volume is equal to 1/3 times 16 pi times 11. Now, I don't know what that is off the top of my head, so let's pull out our handy-dandy calculator. So we're going to go 16 times 11 is equal to 176. So I'm going to rewrite this in a way that makes it exactly the same, but it's just a little nicer looking. So we're going to get 176 pi divided by 3. Can we divide 176 by 3? No, we can't. This is our exact answer. 176 pi divided by 3. Find the dimensions of a cone that is similar to the one above. So, similar, meaning it has to have a similar height and a similar ratio. So that ratio of those two has to be the same. I'm just going to make it easy on myself. What is 11 divided by 5 is equal to 2.2. So then I'm going to say that my radius is 1 and my height is 2.2. Now this cone is similar to the one above. And I'll leave you guys to calculate the volume of the cone that you create. We did density last week, so I'll let you guys do that problem too. Actually, I'll do this one. Gold has a density of 19.32 grams per cubic centimeter. If a square pyramid has a base edge of 5 centimeters. All right, so we have a square pyramid. Square pyramid has a base edge of 5 centimeters. I don't know what just happened there. Oops. 5 centimeters and a height of 6. And a mass of 942 grams. Is the pyramid in fact solid gold? So we need to find if the density is equal to 19.32 grams per cubic centimeter. If it is not, what reason could you explain why it is not? Recall that density can be calculated with the formula density equals mass divided by volume. So let's find the volume. Let's find the volume of this. So volume is equal to 1/3 base area times height. So volume equals 1/3 times our base area is 25 and our height is 6. Well, I'm going to make this easy on myself, and 6 times 1/3 gets us 2. 25 times 2 is 50. So we have 50 cubic centimeters. Now let's see if 942 divided by 50, what does that equal? And again, I'm going to pull out my handy-dandy little calculator right here. 942 divided by 50 is 18.84. So we have 18.84 grams per cubic centimeter. Now, why could this... So it's not solid gold. Why could this not be? Well, you're going to have some... Depending on how you made this, whether it's forged, whether it's... pressed, whether it's there's a few other terms. I only know this because of wheels and rims and how those are made. But it depends on how you make this, and you could have air bubbles in here. There's a lot that could be going on that would make this not solid gold. Maybe the gold we got it from wasn't solid anyways. Maybe it wasn't 100% pure gold. Who knows? There's a lot of things, but it could have it mainly had to do with the way it was forged and made. In the problem set, there are some of these that I really want to do. Like number 1, find this volume. So this is a quarter of a pyramid. If you guys were to look, this is a quarter of a pyramid in here. So let's find the volume. Well, if we were to do this, this would be 5 here. And let's say that it's the same all the way around. So we have a rectangular base that is 8 by 6 with a height of 6. And sorry, that's not 8 by 6. Inside is 8 by 6, short edges. So that drawing's off. All right, I got to draw this out. So that's 8. That's 6. And our height here is again 6. So the overall height is 6. Now, again, this has to be a kite or a this has to be a kite. And so to find the area of a kite, what we're going to want to do is the area of a kite is equal to diagonal times diagonal divided by 2. And since this is a kite, the area is going to be equal to 8 times 3 divided by 2, which is 24 divided by 2, which equals 12. So that base area of the full thing is equal to 12, which means our volume of the whole thing is 72. They don't give us units. Units cubed. Now, that's the whole thing, but we're just looking at 1/4 of it. So we're going to divide 72 by 4, and we're going to get, I want to say it's like 18. Yeah, it's 18. 18 units cubed is our final answer for the volume. Now, do you guys see how I did that? I hope you guys do. I saw that this was just 1/4 of a pyramid, and so I built that pyramid. And then I used the area of a kite to find the base area, multiplied it by the height to get the volume, divided by 4 since I knew this was a fourth. And now the other one I really want to do is down here, number 12. I really want to show you guys how we're going to do this. Let me plug in my laptop real quickly because the battery's about to die. So a bulk tank contains a heavy grade of oil that is to be emptied from a valve into a smaller 5.2 quart container via a funnel. To improve the efficiency of this transfer process, Jason wants to know the greatest rate of oil flow that he can use so that the container and funnel do not overflow. The funnel consists of a cone that empties into a circular cylinder with the dimensions as shown in the diagram. Answer each question to help Jason determine the solution to his problem. So we're going to find the volume of this funnel. And so the easy part is just finding the volume of down here first. So, and I'm going to move this over to the side so I have more space to work. So volume of cylinder. Well, if our diameter is 3/4, our radius is 3/8. So we're going to get 3/8 squared times pi times 1. Now, I don't know what 3/8 squared is, but I'm going to leave this in an exact answer. So this is going to be 9/64 pi. Now, finding the volume of this cylinder part is going to be a little bit tougher. Or this cone part is going to be a little bit tougher. What we're going to have to do is finish out this cone. And not only do we have to find the volume of the full cone, we have to find the volume of this little black section down here as well to subtract from that. So what I'm going to do is I'm going to call this length right here x. Why is that so thick? I'm going to call this length right here x. So what I'm going to do is I'm going to use similar triangles here, guys. So we know that 6 divided by 5 plus x is equal to 3/4 divided by x. So we cross multiply, we're going to get 6x is equal to 15/4 plus 3/4 x. Now let's multiply both sides by 4 because I hate having fractions. So we're going to get 24x is equal to 15 plus 3x. Subtract 3x from both sides, you get 21x equals 15. Divide both sides by 21, you get x equals 15 24ths, which really, if we can take a 3 out of both of those, so let's make it 5/8. So the entire height of this cylinder, or of this cone, so to find the volume of the cone, we know that it's 1/3 base area times height. And so in order to do this, what we're going to want to do is we're going to plug in these numbers. So the volume of the cone is equal to 1/3. Well, we don't know our base area. Actually, we can find our base area. Sorry about that, guys. We can find. I got a little distracted. I got a call on my phone. We can find that base area. It's going to be this. We take this 6 inches and we divide it by 2 to get our radius, and we get pi r squared. So we're going to get times 9 pi times our height of 5 5/8. 5 5/8 is 45/8. So the volume of the cone is equal to 3 pi times 45/8. And now I don't know what 3 times 45 is, so I'm going to check my handy dandy calculator. 3 times 45 is 135. So we're going to get 135 pi divided by 8. And now, in order to find the total area, actually we need, sorry, I'm getting ahead of myself here. We need to find the volume of the smaller cone. I'm going to use this one in green. So to find the area of the smaller cone, we're going to follow that same process. So 3/8 squared, so 9/64 pi. What did I just do? Times our height of 5/8. Well, that's going to give us, multiply straight across, we're going to get 45 pi divided by, okay, no, I'm not doing that. I'm going to make it easier on myself. It's going to be a few more steps, but I'll just make it easier on myself. So 3 pi over 64 times 5/8, which is equal to 15 over, what is 64 times 8? 64 times 8 is equal to 512. So 15 512ths. Let's see, can we take a 3 out of that? We cannot. There's really nothing we can take out of that. So we got 15 pi divided by 512. Now we're going to have to subtract these two. And so let's get this in terms of 512ths. 512 divided by 8 is 64. So we need to multiply all of this by 64. So 135 times 64 gets us 8,640. Pi divided by 512 minus 15 pi divided by 512. Well, what that gets us is 8640 minus 15 times pi divided by 512, which gives us a final answer for the volume of this cone being 8,625 pi divided by 512. And that is no nice number, guys. That is not nice at all. I'm going to leave it that way. And then what we're going to do is we're going to add the volume of that cylinder. So we're going to go plus 72 pi divided by 512, which gets us a grand total of 8,697 pi divided by 512 as our volume. That was rough. That was rough. I'm going to leave the rest for you guys to do. As always, guys, make sure you hit like, make sure you subscribe, and make sure you guys ring that notification bell. As always, guys, enjoy the math. This is going to be the only video for the week because we have one lesson this week.